Assalamualaikum. My name is Tariq Baik and I would like to start the presentation with the introduction of chloroform. There are 4 points that I will be presenting, which is the definition of chloroform, where you can find chloroform, structure, physical and chemical properties of chloroform, and the danger of exposing to chloroform. Okay, the first point is the definition of chloroform, which is chloroform, often known as trichloromethane, is an organic compound having the chemical formula of CHCl3 when breathed or swallowed. It has strong anesthetic, euphoriant, anxiolytic, and sedative properties. Chloroform is a man-made byproduct produced when chlorine is used to disinfect water. Chloroform is also widely used in industrial process. The second point is where you can find chloroform. Low levels of chloroform are found in the air and in coastal waters, inland rivers, lakes, and groundwater. Levels can be greater in industrial regions as well as in the air above chlorine-containing swimming pools. The entire worldwide flow of chloroform through the environment is around 660,000 tons per year, with roughly 90% of emission coming from natural sources. Many types of seaweed create chloroform, and it is expected that fungus makes chloroform in soil. Although the mechanism is unknown, the abiotic process is thought to contribute to natural chloroform formation in soils. Chloroform rapidly volatiles from soil and surface water and degrades in the air to create 4G, dichloromethane, formyl chloride, carbon monoxide, carbon dioxide, and hydrogen chloride. It has a half-life of 55 to 620 days in the air. Water and soil biodegradation are slow. Chloroform does not bioaccumulate effectively in aquatic species. My third point is the structure, physical, and chemical properties of chloroform. The first one is the structure of chloroform. The chloroform Lewis structure is addressed according to the chemical formula, which is CHCl3. The other names for chloroform are trichloromethane, formyl trichloride, and trichloroform. The molar mass for the chloroform is 119.38 g-mol. Thus, the structure of the chloroform is tetrahedral. The second one is the physical properties of chloroform. Chloroform is a colorless liquid with an ether-like odor. The density of chloroform is 1.9 g/cm3. The boiling and melting points for chloroform are respectively 61.2 degrees Celsius and -63.5 degrees Celsius. It is insoluble in water and is soluble in benzene, diethyl ether, and carbon tetrachloride. It is not flammable. The last one is the chemical properties of chloroform. Chloroform is a non-polar solvent because the molecule contains 3 chlorine atoms which have a high electronegativity. They are oriented in opposing direction, resulting in a low moment dipolar total. Furthermore, because chloroform is low reactive, it may be utilized as a solvent in variety of organic chemistry reaction. My last point is the danger of exposing to chloroform. Most people are exposed to chloroform through food, drinking water, and indoor air. The first one is through air. Breathing chloroform containing air over a short period of time may produce headache, weariness, and dizziness. In addition, inhaling chloroform contaminated air for an extended length of time can harm the brain, liver, and kidneys. It has also been linked to development of cancer. Next is through food and drinks. Drinking or eating chloroform-contaminated water or food for an extended length of time might harm the liver and kidneys. Touching liquid chloroform may cause skin irritation and blisters. Chronic exposure to chloroform, according to medical research, might cause dizziness, fatigue, sleepiness, memory impairment, increased dreams, anorexia, and palpitations. Slight liver damage may occur, resulting in increased serum peralbumin and transferrin concentration. That's all from me. Now, I'll pass the presentation to the next presenter.
Thank you, Tariq. Assalamualaikum and good day to everyone. My name is Muhammad Zarif Hazim bin Kamal Zaman, and I am going to present about the flow diagram, block flow diagram, and the calculations. The flow diagram defines as a schematic representation of the sequence of all relevant operations occurring during a process and includes information considered desirable for analysis. The flow diagram illustrates the relationships between major components at an industrial plant. It is most often used in chemical engineering and process engineering, though its concepts are sometimes applied to other processes as well. It's used to document a process, improve a process, or model a new one. It's also used to standardize a process for optimal efficiency and repeatability. Next, the block diagram is defined as a flowchart that formalizes graphic representation of a logic sequence, work or manufacturing process, organization chart, or similar formalized structure. The purpose of a flowchart is to provide people with a common language or reference point when dealing with a project or process. Flowcharts use simple geometric symbols and arrows to define relationships. That's all from now. I'll pass this presentation to the next presenter before explaining the calculations.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Rahman Hamimi and I will explain to you about the description process of making chloroform. First of all, chloromethanes, namely methyl chloride, which is CH3Cl, methylene chloride, CH3Cl2, chloroform, CHCl3, and carbon tetrachloride, CCl4, are produced by direct chlorination of Cl2 in a gas phase reaction without any catalyst. The reactions are very exothermic. The feed molar ratio affects the product distribution. When CH4 or Cl2 is about 1.8, then more CH3Cl is produced, which means that we will make more chloroform. On the other hand, when methane, which is CH4, is chosen as a limiting reactant, more of CCl4 is produced. Therefore, depending upon the product demand, the feed ratio is adjusted. Okay, now I will explain to you about the reactions that occur during the chlorination route. First of all, methane is reacted with chlorine gas to form methyl chloride and hydrochloric acid. Next, methyl chloride is reacted with chlorine gas to form methylene chloride and hydrochloric acid. After that, methylene chloride is reacted with chlorine gas to form chloroform and hydrochloric acid. And last of all, chloroform is reacted with hydrogen to form carbon tetrachloride and hydrochloric acid. Okay, now I will explain to you about the process of making chloroform. First of all, methane and chlorine gas are mixed and sent to a furnace. Depending on the product distribution desired, the methane gas or chlorine gas ratio is chosen. The product gases enter an integrated heat exchanger that receives separated methane gas or a mixture of methane and nitrogen gas and gets cooled from the furnace exit temperature, which is about 400 degrees Celsius. Eventually, the mixture enters an absorber where water is used as an absorbent and water absorbs the HCl or hydrochloric acid to produce 32% of hydrochloric acid. Then, the gas is actually compressed and sent to a partial condenser followed with a phase separator. The phase separator produces two streams of liquid, which is namely consists of chlorides and unrated methane or nitrogen gas. The gaseous product enters a dryer to remove H2O from the vapor stream using 98% sulfuric acid as the absorbent for water from the vapor. The chloromethanes enter a distillation sequence. The sequence consists of columns that sequentially separate CH3Cl, CH2Cl, CHCl3, and CCl4, which is methyl chloride, methylene chloride, chloroform, and carbon tetrachloride. That is all from me.
For the calculations, we are using the basis of 1000 kg per hour of mass flow rate. The moles fraction for both reactants, which is methane and chlorine, is 0.5. Moles fraction for the product, which is chloroform, is 0.19. The moles of side product for chloromethane is 0.37, dichloromethane is 0.41, and 0.03 for tetrachloromethane. To calculate the overall mass balance for input stream, for the value of mass flow rate of methane, the value of basis, which is 1000 kg per hour, needs to multiply it with the moles fraction of 0.5, and the value obtained is 5000 kg per hour. For flow rate of chlorine, it is the same as methane, since the process requires the moles of both reactants to be the same. To calculate the mass flow rate for the output stream, we need to use input equals to output to determine the value. By doing so, the value of mass flow rate for output stream is 1000 kg per hour. Finally, to calculate mass flow rate for the product and the side product, we need to multiply 1000 kg per hour with the moles fraction for each product. With that, we can get the value for the mass flow rate, which is 370 kg per hour for chloromethane, 410 kg per hour for dichloromethane, 1090 kg per hour for chloroform, and 30 kg per hour for tetrachloromethane. As you can see, the mass flow rate of production of chloroform at the product stream is 1090 kg per hour. That's all from me. Now I'll pass this presentation to the next presenter. Thank you.
There are lots of examples about the usage of chloroform. So I will explain some of the examples about the usage of chloroform. Okay, number 1, chloroform is used as a solvent. It helps dissolving other compound. Chloroform is also used in the paper and board sectors construction. It is also used in the pesticide and film production. Second one, chloroform is also used in the production of fluorocarbon 22. Fluorocarbon 22 is a refrigerant. So, chloroform is also used in the production of refrigerant. Until the mid-19th century, chloroform was used as an anesthetic to relieve pain during medical operations. Unfortunately today, chloroform was no longer used because of its harmful effects on human health. The rise of gas anesthesia using nitrous oxide, improved equipment for administrating anesthetics, and also the discovery of hexobarbital has led to the gradual decline of chloroform narcosis. Okay, for conclusion, chloroform also has its own advantages and disadvantages. First of all, I will explain a little bit about the advantages. Okay, for advantages of chloroform, number 1, patient will not suffer pain during medical operation such as surgery. Number 2, it was a huge breakthrough in medical operation, and there could be more improvement in terms of medical operation based on the research of chloroform. Number 3, doctors can perform more complex operation and explore more about human body. Number 4, fewer patients will die in shock if chloroform was being used. Number 5, better anesthetic could be produced if the research of chloroform was continued. Okay, for the disadvantageous part, number 1, doctors could not train their quick surgery skills to prevent so much pain to the patient. Number 2, chloroform has not been tested, so nobody knows about its effects and long-term effects. Number 3, some people have died because they were overexposed to chloroform. Number 4, more complex operation could lead to more infection and more death. Number 5, some people think that anesthetic is unnatural and pain is a gift from the gods. So people need to feel the pain. Okay, I think that is all from our group. Thank you.